All right, transformations consist of translations, reflections, and rotations. So for the translation, that's the slide, and we'll change our x and our y based on whether we're going, the x is left and right, and the y is up and down. So this one, for example, might be something like x plus 3 to make it go 3 to the right, and y minus 2 to make it go 2 units down. All right, the other transformation we have is the reflection, and our ordered pairs start off x and y, and we can reflect over the x-axis by changing the y to the opposite, or we can reflect over the y-axis by changing the x to the opposite. So these are what the reflections will look like algebraically. And then we have the rotations, and the rotations are the hardest for me to remember. So we start off with our regular x and y, the 90-degree clockwise rotation, the x and the y switch places. And they also switch places on the 270 clockwise. And on one of them, the x turns opposite, on one of them, the y turns opposite. I can't remember that, but I can use the graph and figure out which one it is. Now, the 180 rotation, the x and the y stay in the same spot, but they both turn negative. So it's a little bit different than the reflections, because with the reflections, the x and the y stay in the same location, but one of them turns opposite. With the 180, they both turn opposite. So I can kind of narrow it down just using that. All right, so the first example here, we want to know which rule describes the transformation that was used to form parallelogram ABCD prime. So the original one is right here, ABCD, and here's the new one. Okay, well, I need to look and see, is it a reflection, translation, rotation? So it looks like it's going to reflect and translate. So it's reflected over the y-axis, so that's going to make it be the y stays the same, the x turns negative. So it reflects over, and then it looks like it's going to go down 1, 2, 3 units. So that would mean I would subtract 3 from y, and that would give me j. All right, this transformation, it's going to be after a clockwise rotation of 180 about the origin, which in 8th grade it's always about the origin, which algebraic representation can be used to obtain the coordinates of the new quadrilateral. Okay, well, I know this is a reflection because the x has changed opposite. So that's a reflection over the y-axis because the y didn't change. Okay, and I remember this is a 180-degree rotation. And I remember these are either 90 or 270. But I don't really remember those off the top of my head. So if you can't remember this, just pick some points and use these points. So if I use B, okay, point B is at 0, 3, and B prime is at 0, negative 3. Well, 0 is not going to be the best option because it's not either negative nor positive. But I can at least tell that the y's are going to change to the opposite. All right, so if I pick, let's use this C coordinate. All right, so C is at negative 2, positive 3. And C prime is at positive 2, negative 3. So my 180-degree rotation has both of them changing to the opposite. So this was negative, now it's positive. That's what happens when I multiply by negative. This was positive, now it's negative. So I can tell the 180-degree rotation would be G. All right, for the transformations, reflections are the ones that flip. So reflections flip. That FL is for flip. And rotations, that T is for turn.